I've spent a lot of my life in places most people try to avoid. My first job was at a Denny's in Portland, Oregon. I was a dishwasher, I was a busboy, and eventually I was a waiter. I cleaned the toilets. I've probably cleaned more toilets than anyone else in this room, and I say that not to be funny, but because it taught me something fundamental about life and about building a company. It taught me that there is no job beneath you. If you are going to do a job, you do it with every ounce of your soul. You make those toilets the cleanest toilets in the history of that restaurant. You clear those tables with the speed and precision of a world-class athlete. When you approach every task with that level of intensity, you develop a certain kind of humility, but also a certain kind of resilience. You learn how to work hard, and more importantly, you learn how to find dignity in the struggle. That humility is at the very core of NVIDIA. People see us today and they see a successful company, but they don't see the sweat and the grease from the Denny's years. They don't see the moments where we were facing absolute extinction. They don't see the culture of a company that has been 30 days from bankruptcy for 30 years. We have always been a company that seeks out the impossible jobs. We look for the problems that are so difficult, so painful, and so seemingly unsolvable that no one else wants to touch them. Why? Because if it were easy, someone else would have done it already. And if anyone can do it, there is no unique value to be created. We want to do the work of our lives, and the work of your life should be to build things that did not exist before you arrived. This philosophy of pursuing the impossible is why we are here today. We are at a moment in time where the very foundation of computing is being rewritten. For 60 years, the industry lived by a very simple rule, Moore's Law. We expected that every couple of years, transistors would get smaller, CPUs would get faster, and the world would just keep turning on the same axis. But physics has a way of asserting itself. You can only shrink a transistor so far before the heat and the power consumption become insurmountable. Moore's Law is dead. It isn't just resting, it is over. And because Moore's Law is dead, the traditional way of building computers has hit a brick wall. Think about the old model, general purpose computing. You wrote software, line by line, and the CPU executed those instructions one after another. It was a beautiful era, but it was an era of retrieval and basic calculation. We are now entering the era of generation. We are moving from a world where computers calculate to a world where computers generate intelligence. This is the second industrial revolution. In the first one, we used steam and water to automate manual labor. In this one, we are using accelerated computing to automate intelligence. Data goes in and intelligence comes out. And just like the steam engine required a new kind of infrastructure, this new era requires a completely new stack. We realized this nearly 20 years ago. We saw that the only way forward was accelerated computing. We decided to rethink everything, from the chips to the systems, to the software, to the algorithms. We spent decades and billions of dollars building CUDA, building a platform for a world that didn't yet exist. We chose the hard path. We chose to solve the problem of parallel processing when the rest of the industry thought it was a niche hobby for gamers. Now, that niche has become the engine of the global economy. Today, we are taking the most significant leap in that journey. We are here to talk about the moment when the digital world finally, fully meets the physical world. We are here to talk about the moment NVIDIA robots woke up. We call this project GR00T. It is our foundational model for humanoid robots. But to understand GR00T, you have to understand the impossible problem of robotics. For decades, robotics has been a series of scripts. If you wanted a robot to move an arm, you had to program every joint, every angle, every force. If a single variable changed in the environment, if a box was slightly tilted or the lighting changed, the robot failed. It wasn't intelligent. It was just a very expensive puppet. To solve this, we had to go back to first principles. We asked ourselves, what is the most difficult environment for a robot to navigate? The answer is the human world. Our world is built for us. The height of the stairs, the weight of the doors, the layout of our kitchens, it's all designed for the humanoid form. If we want robots to be truly useful, they have to fit into our world. They have to be humanoids. But building a brain for a humanoid is perhaps the hardest problem in the history of technology. A humanoid has to perceive the world in 3D, it has to understand the laws of physics, it has to reason about its next move, and it has to execute that move with millisecond precision. It has to learn how to walk, how to balance, how to interact with objects, and how to stay safe around people. You cannot program this. You have to train it. You have to create a software 2.0 for the physical world. This is where Project GR00T comes in. GR00T is a general-purpose foundation model that allows humanoid robots to learn from a small number of human demonstrations and then generalize that behavior to the real world. But how do you train a robot to not fall over? How do you train it to not break a glass? You can't do it in the real world. It would take too long and you would break too many robots. You have to do it in simulation. We built the Omniverse to be the training ground for the future of intelligence. Omniverse is not just a graphics engine. It is a physical simulation engine that obeys the laws of gravity, electromagnetism, and light. We created a world called Isaac Lab, where we can put thousands of digital twins of robots into a virtual gym. In this digital gym, time is compressed. A robot can live for 10,000 years in a single afternoon. It can fail 1,000,000 times, fall over 1,000,000 times, and learn from every single mistake without ever damaging a piece of metal. We are using AI to build the AI. We use our large language models to describe a task, and then we use our reinforcement learning systems to teach the robot how to perform that task in the Omniverse. This is the virtuous cycle of the new industrial revolution. We are using the power of Blackwell, the most advanced GPU architecture ever created, to run these simulations at a scale that was previously unthinkable. Blackwell is not just a chip, it is the engine of the robot's mind. It provides the trillions of operations per second required to process the vision, the touch, and the reasoning all at once. People often ask me about our organizational structure at NVIDIA. They wonder how we move so fast. It's because we don't have a hierarchy of status. We have a hierarchy of ideas. We have a flat structure because in a world that is moving at the speed of light, you cannot wait for information to travel through 5 layers of management. I want to hear from the engineers who are struggling with the physics of a humanoid's ankle joint. I want to know about the failures in the simulation as soon as they happen. We are a company of learners. We assume that we are wrong until the physics tells us we are right. This resilience, this willingness to face the pain and suffering of constant failure, is what allowed us to reach the moment where Project GR00T woke up. I remember the first time we saw the model generalize. We had trained a robot in simulation to perform a simple task, and then we put the model into a physical humanoid robot that it had never seen before. We didn't give it any new code, we just turned it on, and the robot started to move. It adjusted its balance, it perceived its environment, it performed the task. It was as if a light had been switched on inside the machine. It wasn't just following a script, it was understanding. This is the iPhone moment for robotics, but it is much more profound. When the iPhone arrived, it changed how we interacted with the digital world. Project GR00T is going to change how the digital world interacts with us. We are entering the age of the sovereign AI, where every nation and every company will want their own fleet of intelligent robots to help build their infrastructure, manufacture their goods, and care for their citizens. I want you to feel the urgency of this moment. Run, don't walk. The pace of innovation in physical AI is accelerating faster than anything we've seen in the history of the company. If you are waiting for the perfect time to jump in, you are already too late. The tools are here, the platform is here, the models are waking up. We are no longer just dreaming about a future with robots, we are living in the first days of that future. Every day at NVIDIA, we wake up and we ask ourselves, what is the most impossible thing we can do today? We don't look at the competition, we don't look at the market share, we look at the first principles, we look at the laws of physics, we look at the raw potential of accelerated computing, and we run. We run as if our lives depend on it because we know that the window of opportunity is always closing. When you see a humanoid robot powered by GR00T, I want you to see more than just a machine. I want you to see the culmination of 30 years of survival. I want you to see the spirit of the busboy at Denny's who refused to do a good enough job. I want you to see the humility of a company that was willing to admit it was wrong so that it could eventually be right. We are building the future brick by brick, transistor by transistor, and we are doing it because we believe that the work of our lives should be to expand the boundaries of what is possible for humanity. The transition to a world with intelligent humanoid co-workers is not a scary prediction. It is a vision of abundance. It is a world where we can solve the labor shortages in manufacturing, where we can build things more safely, and where we can free humans to do what they do best, create and imagine. But to reach that world, we have to be willing to do the hard work. We have to be willing to solve the impossible problems of perception and reasoning. We have built the stack. We have the Blackwell GPUs to provide the power. We have the NVLink to provide the communication. We have the Omniverse to provide the simulation. And now we have GR00T to provide the intelligence. The moment the robots woke up was not an accident. It was the result of a rigorous, relentless pursuit of a vision that almost everyone else thought was impossible. Impossible until it wasn't. You see, the moment we saw these machines begin to adapt was a shift in our understanding of what a computer actually is. We've always thought of computers as machines that we command. But with Project GR00T, we are moving to a world where computers are machines that we teach. This is a profound change. It is the transition from the era of software 1.0, where humans wrote the algorithms, to software 2.0, where data and experience are the programmers. In this new world, the robot's manual is the library of millions of simulated experiences it has had in Isaac Lab. It doesn't just know how to pick up a cup, it understands the concept of a cup, the friction required to hold it, and the gravity that acts upon it. This understanding is what we call the world model. To build a world model, you can't just use text or images. You have to use the laws of physics. That is why our work in accelerated computing is so vital. You cannot run a world-scale physics simulation on a traditional CPU. It would take centuries. But on a Blackwell-powered supercomputer, we can simulate the physical reality of 1,000 robots simultaneously. We are essentially building a matrix for robots, a place where they can live, learn, and fail until they are perfect. When they finally wake up in the real world, they aren't seeing it for the first time. They are seeing a reality they have already mastered 1,000,000 times over in the digital realm. This is the first principle of the new robotics. The digital twin is the prerequisite for the physical reality. At NVIDIA, we have committed ourselves to this principle with a level of intensity that many find obsessive. But that obsession is born from our history. We remember the Riva 128. We remember being 30 days from the end. That pressure taught us that you cannot afford to be almost right. In robotics, almost right means a robot that falls over or a robot that causes an accident. To get it exactly right, you have to embrace the struggle of simulating every possible edge case. You have to desire the pain of the engineering process because that is where the safety and the intelligence are forged. I often think about the structure of our company in this context. We are a flat organization because we are a learning machine. If we were a traditional hierarchy, the insights gained by our robotics engineers in the lab would take months to reach our chip designers. But at NVIDIA, they are the same team. The people building the GR00T model are talking directly to the people designing the Blackwell architecture. They are telling them, we need more memory bandwidth for real-time spatial reasoning, or we need lower latency for the tactile feedback loops. We build the silicon to serve the AI, and we build the AI to push the silicon to its absolute limit. This is the only way to solve the impossible. When I tell you to run, don't walk, I am talking about the window of opportunity that is wide open right now. We are at the very beginning of the humanoid era. In a few years, these robots will be everywhere. They will be in our factories, helping us build the next generation of electric vehicles. They will be in our warehouses, managing the logistics of a global economy that never sleeps. And eventually, they will be in our homes, helping us with the tasks of daily life. This is not a distant vision. It is happening today. The companies that are embracing Project GR00T and accelerated computing right now are the ones that will define the next 50 years of industry. We have partnered with the world's leading humanoid robot companies, Agility Robotics, Aptronic, Figure, Sanctuary AI, and many others. We are providing them with the brain, the Jetson Thor computer, and the foundational model, GR00T. We are giving them the tools to move from hard-coded robotics to generative robotics. This democratization of intelligence is the core of our mission. We want to empower every engineer, every researcher, and every startup to build their own metal coworker. Think about the implications of this for a moment. For the first time in history, we are decoupling labor from human physical limitations. We are creating a world of abundance. If we can build robots that can build other robots, if we can build machines that can work in environments that are too dangerous or too difficult for humans, we can solve the most pressing challenges of our species. We can build the infrastructure for clean energy, we can explore the furthest reaches of our solar system, and we can provide care and dignity to an aging population. This is the truth of the second industrial revolution. Intelligence is the ultimate resource, and we have found a way to manufacture it. But this journey requires a special kind of resilience. There will be setbacks, there will be robots that fail, and models that need to be scrapped. At NVIDIA, we welcome those moments. We don't see them as failures. We see them as data points. We see them as the suffering that is necessary to build character in our technology. If we weren't failing, it would mean we weren't reaching far enough. We are reaching for the moment where the machine becomes a partner, a collaborator that understands our world as well as we do. The Blackwell architecture is the foundation of this partnership. It is the most complex system ever built by human beings, designed specifically to be the engine of the AI factory. It features a second-generation transformer engine that is optimized for the very models that power GR00T. It allows for a level of communication between GPUs that makes a cluster of chips behave like one giant unified brain. This is what it takes to wake up a robot. It takes a staggering amount of compute, delivered with zero latency and perfect reliability. I want you to look at the future not as something that is happening to you, but as something you are building. The tools are in your hands. The 50 series on your desktop, the Blackwell systems in the data center, the GR00T models in the cloud. These are the instruments of your imagination. We have done the impossible work of building the stack. Now it is up to you to use it. The era of the general purpose world is fading. The era of the accelerated world is here. We are no longer waiting for the future. We are generating it in real time. Every simulation you run, every model you train, and every robot you deploy is a step toward a world that is more intelligent, more productive, and more human. Yes, the coworker is metal, but the purpose is human. The goal is to amplify our own potential, to allow us to reach higher and see further than ever before. As we conclude this moment, I want you to remember that NVIDIA is, at its heart, a company of dreamers who aren't afraid to get their hands dirty. We are still the guys at Denny's, cleaning the tables and making sure every detail is perfect. We are still the company that is 30 days from bankruptcy, because that is the only way to maintain the urgency required to change the world. The logical conclusion of Project GR00T is irrefutable. The physical world is the next great frontier for AI. The machines have woken up and they are ready to work alongside us. The only question that remains is how fast you are willing to run. Run, don't walk toward this future. It is the most exciting time to be an engineer, a creator, or a human being. We are the architects of the new age, and the world is waiting for what we build next. I want to thank you for being a part of this journey with us. This community is the soul of NVIDIA. Your passion and your vision are what drive us to solve the impossible. If you want to stay on the front lines of this robotics revolution and see how Project GR00T evolves, please subscribe to the channel and give this video a like. It helps us grow this ecosystem of innovators. And more importantly, if you have questions about humanoid robotics, about the Blackwell architecture, or about how to start training your own models in Isaac Lab, please leave them in the comments below. I, Jensen, will be looking through them and I will respond to your questions quickly. I want to hear your ideas. I want to know what challenges you are ready to tackle. The future is bright, it is accelerated, and it is waking up. Run, don't walk. I'll see you in the future.